Okay, welcome to video number 20 of the Diaries of a Coronavirologist YouTube channel. Today is the 6th of May, and we are up to a little bit over 3.7 million confirmed cases of COVID-19 and about 263,000 confirmed deaths. So my last video that I posted was a fairly long one because it had a presentation attached to it, but I did ask a question regarding how I'm doing this channel, and I'm going to also ask that here because if people were put off the long video, they may not have seen what I was talking about. So I'm getting some good questions in the comments and just not necessarily finding enough time to get around to answering them or writing out proper answers. So I've started to think I should incorporate the questions from previous videos into videos I record, either as a couple of minutes of answering questions at the end of each video or as a Q&A video that's a standalone video. Anyway, thought I'd ask for some input from the people who are watching the channel regularly for which you may prefer. So if you've got any thoughts, comments, either way or not at all, please leave it down in the comments for this video. Okay, so tonight I want to tackle a paper that was published on bioRxiv on the 30th of April. As I've said before regarding bioRxiv, this is a preprint server for scientific work. It's closer to a blog than it is to a peer-reviewed journal, and peer review is the foundation of scientific literature. So anything on bioRxiv has to be taken with a pinch of salt. Now, this article, I am of the opinion, has over-sensationalized its own title, and that has led to it being picked up in a lot of places that have media. For instance, there's an article in the LA Times in particular that's been doing the rounds that have picked up on this and have really over sensationalized the story. So I just want to talk about what was done in that paper and give you the breakdown of why I'm saying I think it's sensationalized. The title of the paper is "Spike Mutation Pipeline Reveals the Emergence of a More Transmissible Form of SARS Coronavirus 2. My big problem is with the inclusion of a more transmissible form in the title for this paper. Now, there is some very interesting data in here, and the pipeline that they've built is great. So there's a lot of isolates of SARS2 that have been taken from patients, and they've had their genome fully sequenced. And what this pipeline is doing is looking to analyze all of that sequenced data to try and find if there's new mutants that are appearing, and whether those mutants might be functionally significant. So it's a great idea, and it's something we definitely need to be doing. My gripe is with this idea of it being more transmissible, as I am of the opinion that there is no conclusive evidence for that. All the evidence is circumstantial or falls into the category of causation versus correlation. So this mutation that they're referring to is in the spike protein, and the spike protein is very important to be looking for mutations occurring in because it's so important for the virus and for us to combat the virus with vaccines. So this is a reminder, or for anyone who's not watched one of my videos before or doesn't know what the spike is, spike's the bit that sticks out, and the spiky bits on the outside of the virus is called spike for coronaviruses. And it's the protein that allows SARS coronavirus 2 to infect cells. I've often used the analogy, and many people do, of a lock and key. So spike is the key, and the cell has the lock of ACE2. So SARS2 spike binds to ACE2, and that's how it infects cells. So if mutations occur in spike, that can indeed impact how infectious this virus is, and therefore impact its transmissibility. And as I say, importantly, it can also impact any vaccine strategies we develop. If you take influenza, we need a seasonal vaccine. Every year we need a new flu vaccine. And this is because the equivalent protein called hemagglutinin, so hemagglutinin is the influenza's equivalent of spike, mutates and it evades our antibody response. So we need a new vaccine. So if indeed there's a lot of spike mutations occurring, we need to know about this for developing vaccines. So it's a great idea. We should be looking at all of this and knowing all of this information. But as I say, my problem is with this firmly stated conclusion of a more transmissible form. So what the study finds is that over time, a virus with a mutation spike has appeared to dominate the people that are being affected and the strains that are being found in people and sequenced. So this mutation is called D614G, D614G. So this is an aspartic acid, amino acid, at position 614, amino acid position 614, that has mutated into a glycine. So that's G. So the D form is the original form, and that was what was predominating in cases in Wuhan when this whole thing started. So most of the cases in Wuhan had a D at position 614. Now what's been found since is that G is apparently dominating in all of subsequent cases. It appears that this G form was found initially in Europe at the end of January and early February, and since then seems to have spread around the world, and most cases now appear to be this G form. And that's kind of how the argument has been built upon it being more transmissible. So just imagine this little scenario though. China enacted a massive draconian lockdown on their population as this outbreak grew. So that can lock down a lot of viruses. There could have been a load of different mutations at position 614, but someone carrying virus that had G at position 614 got out and took that virus to Europe and seeded the European outbreak. That virus then has a head start. So let's just take the dynamics of one person infects two people. So that one person comes in with the G virus, infects two people, that goes to 4, goes to 8, 16, 32, 64. Imagine at that stage, someone with the D mutation appears in Europe and seeds a new outbreak of the D. That 1 will go to 2. At the same stage, the G will be up at 128. The 2 will go to 4. That will go up to 256, and so on and so forth. I'll stop doing the sums before I get them wrong. But you can see in that scenario that even if there's no difference in how well they transmit and you just have this 1 to 2 going, G is going to completely dominate. It just needs a head start, and that exponential growth will separate even further the difference between the two. And there's a limited population. At some point, you start to hit immunity, and this idea of herd immunity, you start to run out of people to infect. So, of course, G is going to start to dominate. Moreover, because it was there first, people with symptoms are further along in their time course, and so they're potentially the ones more likely to go to hospital and have the virus sequenced. So G may just appear as a coincidence of the fact it got there first. So just because it's dominating doesn't necessarily mean it's any more transmissible. So just to build a little bit on that idea, because I just mentioned about maybe people are further along in their time course of disease, so it's people are more severely infected in that sort of hypothetical model I was just portraying. This study did also have data from patients, which is interesting. So they took 453 patients from Sheffield in the United Kingdom and looked to see which virus form they had, be it the D or the G. And they found that in this cohort of people, there was instances of both D and G, but they didn't find any difference in the severity of disease. Neither virus appeared to cause more hospitalizations or fewer hospitalizations. There was no difference between the two. Now, of course, this comes with the caveat that this is a small population in only one part of the world, so we can't necessarily make firm conclusions, but this data does suggest there's no significant difference between the two in terms of severity of disease being caused. There was, however, an interesting feature in that people with the G form appeared to have a higher viral load in their upper airways, and this actually leads into the idea of transmissibility. So what I mean by this is people were being tested for infection by the qPCR method. So I've done a video on that before, but just to recap, the testing to see if you're actively infected searches for signatures of the viral genome, the RNA genome. So when I say that these people in this cohort from Sheffield had a higher viral load, it was that there was more RNA being detected in the people that had the G form than that had the D form. So what that could mean, potentially, is that there's more virus in the upper airways, and therefore when you cough and sneeze and talk, more virus is being expelled. So maybe the G form is indeed more transmissible. Again, my problem with this is there's no substantial evidence for that. We don't even have evidence for this idea that a higher viral load makes it more transmissible for this virus. So again, it's a leap that's being made to hit this firm conclusion of a more transmissible form. The other caveat to mention regarding this RNA viral load I'm mentioning is that a higher detection of RNA doesn't mean there's more infectious virus. So you're just looking for the RNA. However, there is a phenomenon of defective virus particles that can have genetic material that is what comes up as positive, but is lacking other big chunks of the genome. So it's not actually infectious, but you can detect the RNA. Additionally, remnants of viral RNA can stick around for quite a long time, it seems. So there was a study recently done in South Korea that I may devote a whole video to, where there was a suggestion that people were being reinfected with SARS2. But what it turned out is that they just had remnants of the RNA in their system, in their upper airways, that tested positive for PCR, but there was no infectious virus particles there. So the RNA seemed to just hang around. So just because there's a higher amount of viral RNA in the people with the G doesn't mean that there's more infectious virus particles. So you can't draw this conclusion that they are more or that this virus is more transmissible and that those people are going to spread it further. So ultimately, I am clearly of the opinion that this is being massively over-sensationalized. I think the title of the paper is too firm that's been put on bioRxiv. And I don't think if it had gone through peer review, it would have been allowed to have the title saying a more transmissible form. The media reports, like I say, have also been overly sensationalized, blowing up this idea that the virus is mutating so it can spread better, which we just don't have the evidence for. It's circumstantial and inconclusive evidence. More work needs to be done. We need to do lab studies to see if that's the case. So I'm sure people are already doing it to look to see if you put that mutation, if you do the D to G mutation in virus particles, or viruses that have spike and have that mutation, to see if they can infect cells better. It could be the case that that virus is more infective. It may bind to ACE2 better. The key may fit better in the lock. But there's no evidence for that. This paper is just looking at genome sequences that have been taken from patients. And again, with any of these studies, there's sampling issues because we're so massively undersampling the true number of cases. But it could be the case. I do want to stress that while I am, I guess, being very critical of this study, it could be right. We could find when we start looking at these mutations in the lab that indeed that virus is more effective. We might put it in monkeys, for example, and find that it can spread better. But right now, we can't draw those conclusions. It's too early to say, and there is not enough evidence for it. Anyway, I wanted to tackle this story because there's obviously so much interest in this SARS2 COVID-19 pandemic. There's so many preprints going up. There's so many people now working with coronaviruses who've never worked with coronaviruses. It's a hot topic. Everyone's interested. And therefore, it's very easy for things to be sensationalized and blown out of proportion. And part of the reason I started this channel was to try and convey calmer amounts of information. Maybe my criticisms haven't come across as calm. I've tried to keep it not too ranty, but I do want to use this channel as a place to convey solid scientific information and to not overly sensationalize anything, because science is incremental. Science doesn't just have these massive breakthrough moments. It gets built up step by step. And now, possibly more than ever, because of how much work is being put up on bioRxiv, we are seeing every little incremental step along the way. So I wanted to use this video as just a sort of a general word of caution, but also it's made so much news I couldn't not tackle this. Anyway, that's where I'll stop tonight. I've got other videos lined up for things people have been asking for and some other stuff I want to talk about, particularly lockdown and how the kind of strategies that we need to put in place to effectively and safely end lockdown. I think that's what I'll do in my next video. I'll stop there. As always, please stay safe, wash your hands, don't inject bleach or run with scissors, because we're still having to do those silly public service announcements. I'll probably stop that after this video. And keep calm and carry on. We will get through this pandemic.